So let's dive a little bit deeper into generics. You have seen the first example where I showed you how to work with our generics and what the benefits are for using generics. Now let's go a little bit deeper, saying something like maybe you want to, or you can not only use generic types at class level, you can also use them at method level. So I just did a little adjustments for the example. I just didn't want to add these elements. I want to concat the values and appending a space in the middle. And now I want to write a method for that. So let's start with a simple approach, just saying something like public static. I want to return a string, and let's say the method something like concat. Values would be a good name. And at first argument I will use the key value pair 1, and the second the key value pair 2, and we return what's actually done in here. So we call that method on this point in the code. So let's call the method from below. What did we do wrong? Float. Okay. Yes, we don't want to get the values put inside. We want to get the key value pairs be passed to the method. And if we run that method now, you see it just prints out 1.0, 2.0 with a space in the middle. So that's okay. So for some reason we have another two key value pairs. Let's say key value pair 3 and key value pair 4. And we're actually having something like doubles in it. So we just put in doubles. And we want to do the same thing as before. So we want to call the method and say something like concat values key value pair 3 and key value pair 4. And it doesn't work, because method signature simply doesn't work. Even if we would do something like number, in this case it doesn't work, because generic type arguments are not it's not inherited. So even if double and float are something like extending the number class, it doesn't fit here, because the inheritance things from the normal from the normal type system doesn't fit for the generic types in this case. So we can just revert what we actually did here. So there are two options. We can duplicate this method and say something like we have another method that concat values for double for strings with double values. You can try that. Let's say we have this method here, double. And as you see, it doesn't work, because it says something like, oh, we have same erasure types, so the types are getting erased, and we can't do that. We can't even do that, because at runtime these methods would have the same method signature because of type erasure. When you want to know more about type erasure, I will refer to documentation later. So that's not possible. We can't do that. So what else can we do? We can use generic types at method level. So we can say in method level, as same as in class level, we can put in some generic types. Let's say VP, KP. And actually, normally you don't use two-lettered generic types, but in our case I don't want to shadow these key and V here, so I use two letters. And we can do now is we put them in the back here, and now everything works. Why does it work? There's something like type inference when we talk about generic types and generic methods. So these are the generic types for the key and the value, and if we call this method here with key value pair 1 and key value pair 2, this is what is get passed into this parameter here, and key p is this one here, and string gets inferred as type for kp because it's called. So it's a type inference in this case, and float gets inferred here for this class. And so everything is clear. So the same goes for the second example. We infer string for kp and double for vp types, and the method fits. Simply fits because we are passing two of the same type here, same types, and it works. It simply works. It's pretty cool. There may be points where you may want to not concat the values, maybe you want to compare them. Oh, I actually want to show you that it works, so I just run the method. Don't want to give you any wrong information, so I just have to check. So it works. Now we can refactor that method, and maybe you want to compare values. So every one of you should have heard something about comparable interface in Java. And the comparable interface has a method which is called comparator that you have to override if you implement that interface. So, I'm passing only floats and doubles in here, but no one knows about it. So the type VP has no bounds. So it just says something. This has to be of arbitrary type, something of object or anything inherited from object. So it doesn't say you have to be inherited or have to implement methods from the comparable interface. In order to do that, we can use the extends keyword and say something like extends, and you can say put in their interfaces, or if you like, you could also put their classes. And I want it to be comparable of VP. So, why doesn't it work? Because we have string kp value compared to what did I do wrong? Yes. The actual return type isn't string anymore, it's an int, because compared to gives numbers less, equal, or greater than 0, depending on the comparison result. So now it works. So now we have a method that takes key value pairs, which have an arbitrary object, arbitrary type for the key part, and for the value part, it just limits the values to be of a type that is extended from comparable or implementing comparable interface. So that's something that we could achieve. We can also say if we have more classes that we depend on, something like, I don't know, serializable or anything else, a list, or I don't know, you can think of any class, you can put them there too. It all works fine. So that's something like an upper bound. You can put an upper bound that you can say something like implementing the comparable interface, and if you do that, you are able to call special methods from that interfaces that you declared here. You can even put these type of restrictions to your class type arguments here. That's also possible. You can do something like using wildcards. That's mentioned in documentation. I don't want to show you a lot of it because I don't like using wildcards. It's almost always a bad idea to use them, but you will experience that by yourself at some point. And one thing I wanted to mention is the diamond operator. As you see, this is yellow. It's something giving a hint that this something that you can simplify, or there's something wrong. And as it says here, it places a type specification, a constructor calls a diamond operator. We can use a diamond operator here. So it's something we can do. We can just put it here in this case. Why it isn't? Because my language level isn't here, so I'd have to change the language level of my project. But if I do that, I don't want to do that for now. But I actually do that. Let's go to project structure, and it's also, I don't know why it doesn't, is the way everything is fine. I don't know, maybe the language level is not in the build Gradle. Here we go. We can just refresh our language level. Now everything should be fine. In just a second. Hopefully. Build. Yeah, now everything is fine. Now we can use the generic type, the diamond operator in this case, and skip some boilerplate code. What it actually does is the same thing as here, it just infers the type. So here string and float is mentioned, and now the compiler knows if we don't put anything else in here, it's just the same types as from the beginning. So in order to avoid duplicating this code here, we can just skip it so it just looks nice. For further reading, so that's not all that's about generics there, I would like you to read the Java tutorial here. So there's everything that you need to know about generics. Read about the wildcards, why and when you should use wildcards. What is type erasure is a very big part here, and you should be aware of the type erasure things, because if you don't be aware of it, you don't understand why several things don't compile. As the same thing as I mentioned before, if you duplicate the method with the generic types, because of the type erasure, it's not possible. But you have to read that to understand what's actually happening at runtime with the generic types. Please read these documentation till next Tuesday. Try to work it out and ask questions about it if you have any. So after this video, there will be a third video teaching you some things about problems that you might have with generics. There may be some things like mentioned here in the tutorial, but maybe some other things you'd like to know about. So that's it for now and for the basic parts of the generic world. And as I said, if you want to dive in deeper, or you should dive in deeper, you should go to this site here and read the documentation. As I said, read the fucking manual. Bye bye.